Bringing the skills of an engineer to architecture and the vision of an architect to his work as an engineer, Werner Sobek straddles two parallel disciplines, disciplines whose ethical obligations intersect at material innovation, social relevance, and respect for the environment.
When the house was delivered, the steel structure, my wife called me up and they said, the contractor promised us to deliver the house today. What came around the corner is only a part of it. There's a little material on a big truck. You should call him up and tell him that he should deliver the rest latest tomorrow. So I called him up and he said, we delivered everything. It was all on one truck. It's just 10 tons. The primary structure is exclusively bolted. No welding, no gluing, nothing. But you may dismount the structure piece by piece and reuse the element or bring them to a recycling plant. So it's already from its conception a low energy building. Zero energy needed to heat or to cool the house. We provide our own electricity by photovoltaics. Yeah, we have our own fresh air supply. And we have no emissions. The building has no chimney. So it's the right thing to be placed on a green incline like this one. We have the luck here to live in the middle of the nature and to experience nature as changing of the light intensity, changing of the color of the light, laying in your bed and experiencing the snowflakes blown around the house. So this brings you very, very close to what's going on with you outside. And this is a very, very positive experience. What we did here is we transferred the transparency into the third dimension. So looking crisscross up and down diagonal through the building is, at least in my opinion, a big step forward, which comes very close to the living in a soap bubble, which I'm always intending. This question of how do we live tomorrow, how do we work tomorrow, or the day after tomorrow, this is simply the thing which interests me. And what is the architectural implication of those changes?
How will we live tomorrow? In R129, Sobek explores the idea of completely living off the grid and in harmony with nature.
And this is really the first application of load-bearing glues in such a dimension. This is, by the way, the thinnest glass shell ever built. The thickness of the material is 10 millimeter in total, and the span is 8.50 meters, which is a tenth of an eggshell. It's paper thin. This, of course, is the first step to realize glazed elements, glazed shells in a diameter of 20 to 25 meters, as R129 is. But it is also an experiment to show that you can cover hotel atria, swimming pools and other things like this with a non-metallic enclosure. The next idea would be to do a monospace which even has no furniture, where the furniture automatically folds and unfolds out of the floor or from the ceiling, where you have multifunctional furniture. Yeah, the place is simply empty. And then you make a kitchen out of it, or you make a living room out of it, or a sleeping place out of it. The next step would be, just as an experiment, not as a must, but as an experiment to find out what would it mean if you do not have any contact with the building to the public supply systems, to the public grid. Means produce your own clear water, manage your own wastewater and so on, be totally independent, like a space station. The thoughts we have to develop there are the same as I mentioned for the next step for R129, independency from the public grid. So in our institute, we discuss these things, and we look below the stones and we turn the stones around, and we try to find out what is possible in a very radical approach.
not a research for this afternoon, a research for the day after tomorrow.
At the Institute for Lightweight Studies at Stuttgart University, Sobek leads his students in a multidisciplinary approach, devising efficient and sustainable solutions for the building of the future.
We try to enable our students to manage the most complicated, to design the minimum weight structure, which is for structural engineers one of the most complicated things you can do. Isn't it possible that one element which is highly loaded to its maximum at one time and all the others are totally underloaded shares the job it has to do with the other ones by, for example, an artificial weakening of this highly loaded element through transferring loads to the underloaded ones. That if you do it in a clever way, you might save another 50% of material.
This is trying to show how efficient you could build using adaptive elements. And you have one support that's able to move, and you have sensors, and they're measuring the load of the train in every location. And the computer calculates how much this support has to move backwards and forwards to introduce a bending line, which is exactly the opposite of the one introduced by the train. So it always goes horizontally. So it's always showing the passive state, meaning without manipulation, and then coming back you have the active state, where you manipulate the system. What you do is you substitute material with energy. But what you can see here is you don't really need big movements in order to achieve a big change in the system.
If somebody comes up and says, how do I learn to design with a minimum material input? You won't learn that in the architectural faculty. Tell him to go to the aeronautics. He will learn it there. This is what I mean. Teamwork means a common language. And this is a question of education. Only. Bringing the students to the point where they understand what their basic discipline has to do and can do and where the limits are is the one thing. But what you have to do is enable the students to understand the neighboring disciplines. For me, everything installed in this nature is a piece of the built environment, needs a designer responsible for it, and you can't be responsible for a piece of the built environment if you are not educated to design it. Educated in the sense of make it stable, make it beautiful, make it recyclable, make it low energy or even zero energy and emission. If you really want to reach a goal, then you can do it. If you want to create something, there's always a solution. You just must to want it. This is what I'm telling the students.